systems is just the obvious buzzword at this moment. And we're so beyond even arguing about whose ass is at fault for the stuff, right? We're just go to the, right? You got to go to the greenscape and just leave the hard stuff behind.
All right. Well, thank you so much, Brock.
Hi, thank you, madam. Well, see, I can.
And I know. One more little set of things to do this afternoon. I'm going to introduce now Michael McClatchy, and he is going to be facilitating a panel. So Brock will be back on the panel, and a number of other notable figures. And so I know it's this talk that we just heard, I'm hoping will have stimulated questions in your mind, as well as all the things that we went through today and yesterday, and we can talk about how we can really implement some of these ideas at the panel. Oh, Mike is doing a presentation first, sorry. Then we're doing a panel, okay. So I'm happy to introduce Mike McClatchy. I had the pleasure of working with him on another conference, on the CWRA conference in June of last year, and this is where we met. And I'm really glad to have him come back again today. So he's another great knowledgeable water resource we have here. Thank you.
Well, thank you. Actually, I'd be just as fine jumping right to the panel discussion if that's okay. But I was listening to Brock's incredible talk there from the back of the room, realizing that my presentation was coming up, and I started to get this little sinking feeling when I realized that following up Brock's very dynamic talk, I was going to be talking about a position paper, which is probably about as dry as you can get in terms of content. In any case, I hope you won't hold that against me. As the chair of the Stormwater Management Committee at BCWWA, for which I was voluntold by Chris Johnson that I should take that position, we were tasked a few months ago with developing a position paper for BCWWA to address issues of stormwater management. And I'll just give you some overview on that. First, I'll talk about BCWWA's process for developing position papers, some motivations for this particular position paper, some of the background science that goes into where we came up with our position, and then the direction that we've taken with it. And finally, there is an opportunity still for input into this process from BCWWA members and others who have an interest. And that's where we'll end up, and then we'll go to the panel discussion. BCWWA has an established process for developing these position papers. First of all, at some level, generally at the board level or an interested party brings forward an issue, and they identify the topic and they develop a context statement that's supposed to be addressed by an issue analysis paper. The issue analysis paper lays the groundwork for developing the position statement. There's several requirements for the issue analysis paper. It has to be well researched and provide a regulatory context. Content developed from fortune cookie contents is not valid. It has to be factual and scientific based, so reference papers, research, knowledge within the industry. It has to be balanced. It has to present all sides of the issue that's being considered, so pros and cons, limitations, constraints, and things like that. And then from there, from the issue analysis paper, once it's been discussed and accepted by the leadership committee and the board of BCWWA, that leads to the development of a draft position statement based on that issue analysis paper. From there, after a period of communication and consultation, which is hopefully not too long, you arrive at a final position statement as approved by the board of BCWWA, and then that becomes out in the domain for it to provide guidance and advice to BCWWA's members, be they municipalities or other practitioners and things like that. So in this case, the problem statement, innocent as it seems in that one sentence, should appropriate levels of treatment be required for stormwater? I started into the issue analysis paper with committee members, and became apparent quite quickly that even though that would appear to be a focus statement, it was still a very, very broad topic with many facets. So after some discussion and based on the information that's available, it was decided to focus in on issues of stormwater quality or water quality arising from runoff from settlement development areas, by which I mean partially suburban or urbanized areas. And I'm just cautious using the term urban because I don't want somebody from a town to think that, well, they're not a major city, so they're not urban. If you have a standard residential development in a small town, it may only affect one small watershed, but within that small watershed, you'll see the same kind of issues as you would see in a large urbanized area like Metro Vancouver, but spread out over a great many watersheds. So I just, don't assume that when I say urban, I'm just talking about the large Metro Vancouvers of the world. Why are we even looking at this? Well, I think it's already known by everyone in this room, and I'm probably stating the incredibly obvious, but stormwater is known to be impacting receiving waters, be they freshwater or marine or anything like that. So by doing so, it's limiting the use of those waters for what is known as beneficial uses and the legalities of the area. So those beneficial uses can include recreation, body contact recreation like swimming, water skiing. The use of that water for drinking water, it may not absolutely prevent it, but because the water quality is compromised, it may require higher levels of treatment than would otherwise be the case. The water might not be suitable for agriculture, for example, because if it has very high fecal coliforms or things, other pollutants from wash off from the land, it might not be safe to apply to food crops. Industrial uses might be impaired because the water quality is not suitable for the particular use that an industry wants to make of it. And of course, last but not least, very important ecological functions, supporting fisheries, aquatic habitat, various aquatic organisms that fish depend on, all those things, that can be very much compromised by a decline in water quality. Some specific examples, for example, Environment Canada has identified through sediment sampling on the bottoms of harbors, for example in Greater Vancouver, Victoria, that they are essentially contaminated sites. At least some of the contaminants they've detected can be attributed to stormwater, as well as industrial discharges, bilge discharges from ships and things like that. But those contaminants include metals, hydrocarbons, other compounds like pesticides, things like that. Obviously not great to have around. The sediment itself that stormwater can wash off the landscape, off the developed lands, can become a contaminant either from clogging spawning gravels or damaging fish tissue, or because many contaminants bind themselves to fine sediments. So some polyaromatic hydrocarbons, things like that, can become bound to fine sediments, which generally makes the problem much worse. From this, it becomes clear we need to find a strategy for enhancing or protecting the receiving waters to ensure that the quality is retained or improved. It's very hard, oops. It's hard to find visual examples of water quality contamination since many contaminants are not readily visible, dissolved substances and things like that. But here we have some runoff into an agricultural ditch. It's actually coming from an upland area which is developed. And you can see that the water is quite foamy and white, and that's because of some wonderful substances in there like surfactants, probably some hydrocarbons and things like that. And so it very visually demonstrates the impact of the water quality. I'm sure there's probably other things in there that are not visible, high nutrient loads, any number of other things. At the macro pollution scale, we have a couple oil jug containers, antifreeze containers, things like that, various floating debris. Now that's not really what I'm addressing in this paper because obviously that can be handled in a different way. But it does have some good shock value. And that's about the limit of the colorful pictures and slides in my presentation. Conventionally, stormwater management many years back, and even persisting to this present day in some cases, has involved a pipe and convey approach, which several others have mentioned over the course of this workshop. Basically, you gather up the rainwater as quickly as possible, force it into a pipe, and carry it downstream so that it becomes somebody else's problem. In the course of doing that, you increase flow rates and increase the transport and mobilization of pollutants, both from the creek corridor and washing off the land surface. You certainly are facilitating that process that degrades water quality. More recent conventional strategies have at least tried to address the peak flow issue, looking at using various methods to slow down the water, detain it for a period of time, and then release it more slowly as a way of trying to reduce flooding impacts. Generally, these strategies have little or no benefit in addressing the water quality issues that arise. Here is a classic dry detention pond, which it looks really pretty with grass and things around it, but when it floods, all it really does is hold the water back for a period of time. There's very little that pond does to address water quality issues. It probably helps reduce flooding downstream and may help the stream corridor a bit by reducing peak flow rates that cause erosion, but that's about the limit of its functionality. On the water quality mitigation side, there are two sort of distinct strategies or categories of approaches that can be applied to address the water quality. One is source controls, which sort of have two subcategories. One is that you have source controls on site that treat the contamination, take it out of the water, or even better, you prevent the contamination from occurring at the source in the first place. Then there's end-of-pipe treatment processes, which are applied with some degrees of success. You can have a passive treatment system like an engineered wetland, or some kind of active treatment process which involves oil water separators, constructed infrastructure like that. So as I say, there's wetlands, there's proprietary treatment units. Probably the most extreme example I can think of as an end-of-pipe solution for stormwater management is also in place to address CSOs, is Chicago's Tunnel and Reservoir Project, which is a massive project to drill 40-foot diameter tunnels under the city of Chicago with large drop wells and pumping systems that collect the runoff from a storm, and then over time pump it out through treatment plants so that it can be treated pretty much like any raw sewage would be treated going through a treatment plant. As I say, that's a fairly extreme example, and probably represents the fact that Chicago can't go very far in retrofitting to a more green infrastructure or a green landscape in any reasonable timescale. It probably also represents the fact that the EPA was threatening to sue them for tens of millions of dollars for contaminating Lake Erie. So it seems source control approaches are probably a more reasonable answer in many cases. So a shift to source control approaches is definitely already underway in stormwater management. We've seen that talked about several times in this workshop. The original motivation, one of the motivations for source controls is to ensure the sustainability of water courses, that they remain healthy and they preserve their function as aquatic habitat for fisheries purposes, and also just an aesthetic and nurturing role for the community. These needs are compounded by the magnification that climate change will impact on stormwater runoff and the problems that you see in water courses. So generally it involves implementing strategies to control runoff volumes on the site. This can be changes in zoning, landform designs, landscape designs, various kinds of constructed systems like infiltration chambers, any number of things that can achieve that end. While most of them are steered towards controlling runoff volumes, they also have a parallel benefit in that many are fairly effective at protecting water quality. Just as an example here, a semi-pretty photo of a pervious paving application in the Lower Mainland. From far up, you can see that the texture of the pavement is quite a bit different from normal pavement, and in the close-up, you can see that it's very open-looking paving, and what they do is they leave the fines out of the paving structure so that it's open-graded, and it allows water to seep through the pavement into the subgrade, which controls runoff, but also can have an amending effect on the water in terms of treating contaminants and removing them from the water before it makes its way through the groundwater to a creek.